All right. Today's lesson is 39 circumference of a circle. What's our objective, class? Get ready?
Circumference of a circle.
Circumference of a circle. We're going to talk about radius, diameter, the formula for circumference, the two formulas, 2 pi r and pi d, and also the approximations for pi and kind of where pi came from. So the circumference is the distance around the outside. It's called circumference. What does it? Get ready?
Circumference.
Circumference, the distance from edge to edge through the center is diameter. What?
Diameter.
Diameter, and the distance from the center to the edge is radius. What?
Radius.
Radius. So we're going to do a quick circumference example with a wheel. So this is my mountain bike wheel, and I have a bike computer hooked up on my mountain bike so that the computer, this is it sits right on the handlebars, and it tells you how fast you're going, your max speed, how far you've gone, your average speed. It's pretty cool, and it keeps an odometer for your trip or for the entire time you've owned your bike or owned the computer. How does it work? So this little magnet here sits on the spoke, and it's really lightweight. Every time, and on my front forks, on the front of my bike, there's another magnet with a wire that comes up, wraps around, and talks to the computer. So every time the magnet passes the other magnet, so in a revolution, the magnet gets a little electrical impulse. It feels a positive, negative charge, and it sends an impulse up the wire, and the computer starts counting. It went once, twice, 3, 4, 5, 6, 7, 8, 300. And it counts it up. And so what it's doing is counting how many circumferences you've gone in a certain amount of time. So it has a timer going as well. So it's dividing your distance, how many circumferences, dividing by time to give you your speed, among others. All right, so let's start. When I got this set up in my computer, I had to tell it what the size of my bike tire was so it knew how far a circumference was, right? So picture this magnetic strip. Even if it was down here at the edge, it would still revolve in the same complete circle, right? There's one complete circle. So we're going to find out what the circumference is of this tire. We're going to do it like this. I'm going to mark a start point, and I'm going to pretend that we're going to defy gravity, and we're going to ride the bike tire along and measure the length of its circumference. Because I want you to see that circumference is not area, it's really a linear distance. So here's let's use my valve because it's easy to see. Let's use the valve because it's close. I can line that right up. See that? And now I'm going to drive it along the whiteboard, hopefully not slipping and losing any accuracy in my measurements. Now we're going to stop right there. See, there's my valve. Right there. And now we're going to get a linear measurement of that distance. So let me grab our handy dandy, and I need a helper. Jasmine, can you grab the end of this? Yeah. We're going to do the metric side. So you put the end of it right there. Let's find out the circumference of the wheel. So this is the 2 meter mark. This is 10 centimeters. So I've got, let's call this 200 centimeters. 201, 2, 3, 4, 5, 6, 7, 8. 208 centimeters. Or what my bike computer asked for is they wanted it in millimeters, so I had to enter in 2,080 millimeters. Let's do. I have you measure one more thing. Actually, here, wind that up for me. So there's our circumference, the distance of the bike around the outside of the bike wheel. I want to pose to you this possibility. If I took my circumference and divided it by the diameter of the wheel, what would I come up with? Let's find out the diameter. And I'm going to use this measurement. All right, Jasmine, will you hold this up? Okay, and then we're going to find out what the diameter is. And yes, we probably can't get super perfect, but if you could take the end of that and make sure it's kind of on that outer edge of the rubber. Okay. And we're going to have it mostly right up to that axle, as close as we can get it. And it's looking like 67. Do you guys see that? 67 centimeters right there. Okay, you got it if I let go? All right, so we had 208 centimeters over 67 centimeters. Now we need a calculator, and thank you, Jasmine, you did perfect. You can sit down. Who's got a calculator? No, it's kind of fun though, isn't it?
I have one at home.
I have a calculator.
All right,
Did we get our calculator?
calculator 5 came back, so we all have calculators now, but don't pass them out yet. Who's got 208 divided by 67? What do you got?
3.104, that's the 104477612.
And it kind of keeps going. Wow, it's pretty close. Every class has come up with a little different number, but it's pretty close to a special number we want to focus in on, the 3.14 number. If I could have gotten a little more accurate measurement, maybe pumped up the tires was perfect and like really was careful. Every time, if you divide the circumference of a circle by its diameter, you're going to come up with 3.14, and they found that out a couple thousand years ago. Every size of circle they did this to, it always had the same number. It was like right around 3.14. So because that kept coming up, they said, well, let's call it pi. And computers are still calculating more digits of pi because pi is irrational. It's non-terminating and non-repeating. It's like 3.14159265358 and there's some more digits up there, but that's all I have memorized. It keeps going, non-repeating, non-terminating. We approximate pi to 3.14, but we also approximate pi to 22/7. These are close. They're rounded. This is actual pi, okay? And sometimes when we do questions, we don't even need to use one of these numbers. We can use the pi symbol to just express our answer in terms of pi. So we're going to do some of that today. So, getting back to this, we talked about circumference divided by diameter is pi. So that leads us to, remember yesterday's lesson we said, well, what if I wanted to solve for something up here? I needed to get rid of the diameter, and I could do that by timesing by the diameter. Well, look at that. If I put diameter over on this side, I ended up with circumference equals pi times diameter. Boom. Circumference equals pi times diameter. What's my formula starting with circumference? Get ready?
Circumference equals pi times diameter.
Good. And the other formula we commonly use is circumference equals 2 pi times the radius. Why? Because the diameter is twice as big as the radius. The radius is just that small piece. So circumference equals 2 pi r. What's the formula starting with circumference? Ready?
2 pi r.
Starting with circumference. Ready?
Circumference equals 2 pi r.
Here's a fun way to remember diameter. That's diameter goes through the middle, all the way across. Look, it's a capital D. There's your diameter. Diameter, that will help you remember. Okay, we talked about pi as irrational, non-repeating, non-terminating, and we round. All right, let's get calculators passed out because I want everyone to be familiar with pi on the calculator. All right, so let's talk calculators. Most calculators have a pi button if it's scientific. If it's not scientific, you'll need to get one. So we're going to use the school calculator. We're going to clear out what's there. So the pi button is located on the left side, halfway down. This is pi. You can hit pi and then enter, and it'll show an estimated pi. It has to round it at the end because the display can't fit all of them. But if you need to calculate an exact value of pi, use your pi button in your calculator. Some of the calculators, if you go to multiply something by pi, it'll give you your answer. It'll say, that's 10 pi. You're like, no, I want to know what 10 pi equals. You're going to have to change your mode from math print mode to classic mode. So does anybody have, let's see, hold up your calculators. Let me see what calculators you have. Oh, everyone has yours is the one that does math print mode. So, okay, we should be good. All right, so using our calculator, let's do a comparison of these three values, pi, 3.14, and 22/7. So which one is the least and which one's greatest? Where does it fall in the middle? Well, our calculator told us that the real pi is 3.14, 159265, and it keeps going. That's enough for now. And then 3.14 is listed next, and then we got 22/7. Who's got 22/7? Jasmine?
3.14285714.
Okay, we'll stop right there. How about that? Look, they're different. All these approximations for pi, they're a little bit different. They're accurate up to the second digit, so the third digit is what we're really going to compare. Our least digit is the 3.14. Our next digit is the actual pi, And then our next largest one is the 2, and that's our 22/7. So you can see, okay, pi is right in between the two. This is the most accurate. This is the exact accurate one, okay? That one's rounded a little bit less. This one's rounded a little bit higher. So let's do an actual problem. The diameter of a truck wheel is 35 inches. How many inches? Get ready.
35
35 inches. So I'm going to say D equals 35. How far does the wheel roll in one turn? So what they're asking for is that one revolution, that circumference. So before you start, you always think, oh yeah, what's the formula for circumference? Circumference equals pi d. What?
Pi d.
Pi d. Circumference equals pi d. So we're going to say pi times diameter, which is pi times 35. And we always write the coefficient first, 35 times pi. But then what am I using for pi? It says at the end of the question, use 22/7 this time. So we're going to go 35 times 22/7. And how handy, because 7 and 35 are compatible numbers. 7 will go into 35 5 times. I'm left with 5 times 22, which is 110. We're in inches. Units. You saw me drive the bicycle tire across and it was a line. So should my units be singular inches or should it be squared, like inches squared? Lexi?
I have a question. Can you ever use 3/4 or 4 just to multiply?
Only if it tells you to. Great question. But Lexi, since I called on you.
Oh, okay.
Squared or singular?
Square.
No.
Oh, cute.
No. We measure with a tape measure in a straight line, right? So it's just like centimeters or inches. So same thing for circumference. It's just linear. It's just inches. It's not squared or cubed because it's not area. Annika?
So because the circumference is the outside of the circle, could it also count as a perimeter?
It's like a perimeter. So if my bicycle wheel was square, we would be measuring the perimeter. So yes, it's just like the perimeter. Just when it's round, we call it circumference. Okay, here's a fun one. A bike has a chain. It wraps around a sprocket in the front and a sprocket in the rear, and the sprockets are different sizes. Same thing in a car engine. If any of you guys help your dad work in the car, you've got 2 pulleys. Let's do a quick slant check. Slant. Thank you. Kaylee, if you'll go hit the thermostat, hit it down twice and cool it off a little bit here. We've got a small circle, or it's got a wheel with a pulley on it, and a larger one. And there's a belt that wraps around. This is how your engine cools down. These types of pulleys can also help generate power from a lot of machinery. So what we've got is 4 centimeters on this radius, and through this one, they didn't give us a radius, they instead gave us a diameter all the way across. The question is, what's the circumferences of both? So I'm going to call on students. How do I find the circumference of this one? Samantha.
You would do use 2 times 3 or 2 times 5.
She says, let's use the 2 times pi times r, the 2 pi r one, because they gave us the radius. So 2 times pi times 4, or if you wanted to just go, oh yeah, 4 and 4, that would make an 8. So I could go 8 pi, or pi times diameter. On this one, how would I find this one? Rachel. Circumference equals what? What's my formula for circumference? Okay, let's pause. We're on a test. We forgot the formula for circumference. It was in there, but it left. Go to the middle column of my posters. Middle column, second poster down. What is the first formula? Think. Get ready?
Circumference equals pi times diameter.
What's my second formula? Ready?
Circumference equals 2 pi r.
Very good. Hey, since they gave us the diameter, let's use this one. What does that give us, Rachel? Not today. Bo?
So the circumference, that would be, hold on, I'm gonna do it on the calculator.
That's right. Weston? I don't need a calculator. Don't need a calculator. Layla? 12 times pi. You just take the diameter and put a pi after it. You just take the diameter and put a pi after it. It's pi times diameter. What's circumference? Get ready?
Pi
maybe needed to remind you, leave pi as pi. 12 pi, a pi. The question then asked, what is the ratio of the smaller pulley, because it listed it first, to the larger pulley? So I'm going to make a ratio, small to big. Pi's cancel, using my marker. And then my numbers reduce. So I've got 8 over 12. I reduce out of 4, divide out of 4. I get 2/3. So my ratio is 2/3. What does that mean? That means if I took this circumference and look at that linear measurement, that's the distance around the circle. Took the larger one, took that linear measurement. This one's going to be 2/3 the length of the larger one. Why do they use that? Because depending on the ratios of the pulleys, it can generate different amounts of power needed to run that engine or to run that fan belt for your car. So that's definitely a thing that a mechanic would use. If I doubled the diameter of this, I would double the circumference. If I doubled this diameter, I would also double the circumference. And we're going to skip the last question. If it ever asks you, calculate it to the nearest meter, you're going to be using your pi button on your calculator. What will you use on your calculator? Get ready?
Pi.
Your pi button. And then it says round it when you're done. All right, we're on page 260. And take a 20-second stand-up break.